Now, by using this Q's theorem, we can show a result. Find or prove that it is limit sin n by n. Limit sin n by n equals 0. How to prove this one? Limit sin n by n equals 0. How to prove this result? So this result is proved by using this Q's theorem. Why? Because we know that what is the absolute values of all the, we know that modulus of sin n, modulus of sin theta or sin n less than or equals 1. Okay, that means minus 1 less than or equals sin n less than or equals n. Okay, sorry, less than or equals 1. Mod sin n less than or equals 1 means minus 1 less than or equals sin n less than or equals 1. That means minus 1 by n less than or equals sin n by n less than or equals 1 by n. Okay? Okay. Put on xn equals minus 1 by n. Secants xn equals minus 1 by n and secants yn equals 1 by n. These are two sequences. Then clearly we have here xn and zn and sorry, let zn equals but xn equals minus 1 by n and zn equals 1 by n and choose yn equals sin n by n. So from here, from 1 gives xn less than or equals yn less than or equals 7. So this is one of the conditions of Q's theorem. Okay. Moreover, again for applying the Q's theorem, the second condition shall be satisfied. That is, what is limit xn? Here limit xn equals limit of minus 1 by n. Limit minus 1 by n is 0. When n goes to infinity, 1 by n goes to 0. What is limit yn? Limit yn is again limit of 1 by n. What is limit 1 by n? Again 0. So limit xn equals limit yn, that equals 0. But Q's theorem states that when limit xn equals a and limit yn equals a, limit zn equals a, when limit xn equals a and limit zn equals a, then limit yn also equals a. That is from Q's theorem. So here limit xn equals 0, limit zn equals 0 means limit xn equals limit zn. Moreover, xn less than or equals yn less than or equals zn. So by Q's theorem, we can conclude that secants yn converges to 0. Secants yn converges to 0 means that is limit of sin n by n equals 0. So the proof is done by using Q's theorem. Mod sin n greater than less than equals 1. From here we can minus 1 less than equals sin less than equals 1. Again from here. But you can choose xn equals minus 1 by n and zn equals 1 by n. Moreover, yn equals sin n by n. So we have this result xn less than equals yn less than equals zn. That is clear from this one. Okay. And limit xn and limit zn are 0 here. Means they have same limits. So you can apply the Q's theorem. The secants yn also converges to the limit of this xn and by zn, that is 0. Therefore limit sin n by n equals 0. Okay, so this problem is solved by using this Q's theorem. Okay. Again, now consider another result. Using Q's theorem, determine limit term. What about a limit term n raised to 1 by n square? Find the limit of limit n power 1 by n square. How to find out the limit? What is its limit? How to find out this limit? The limit of this sequence n power 1 by n square, n to the power 1 by n square, that can be identified by using skew theorem. How? There exist some sequences that an, sequence an and sequence bn are any two sequences such that an less than or equals this n power 1 by n to the power 1 by n square less than or equals bn and so on. Okay. Now for we know that 1 less than or equals n. 1 less than or equals n for all n following n. Okay? Sure. 1 less than or equals n means, this means 1 to the power 1 by n square less than or equals n to the power 1 by n square. Okay. 1 to the power 1 by n square less than or equals n to the power 1 by n square. Let an or xn, let sequence xn equals 1 to the power 1 by n square. Choose xn equals 1 to the power 1 by n square. What is 1 to the power 1 by n square? It is simply 1. Let sequence xn equals 1. Okay. So what is limit of xn? Limit xn equals limit to 1. That is 1 itself. So we have 1 less than or equals n means 1 to the power 1 by n square less than or equals n to the power 1 by n square. That means 1 less than or equals n to the power 1 by n square. Okay. So choose this 1 as sequence xn and limit xn is 1. Agreed. Again, what is n square? N square should greater than n. For all n following n. N square greater than or equals n for all n following n. When equality holds, put n equals 1. So n square greater than or equals n for all n following. So that means it is 1 by n square less than 1 by n square less than or equals 1 by n for all n following n. Okay. 1 by n square less than or equals 1 by n means, so that therefore n to the power 1 by n square less than or equals n to the power 1 by n for all n following n. Sure? 1 by n square less than or equals 1 by n. Therefore, n to the power 1 by n square less than or equals n to the power 1 by n for all n following n. Then you can choose sequence yn. Sequence yn equals n to the power 1 by n. Choose sequence yn equals n to the power 1 by n. Okay. What is limit n to the power 1 by n? Now, what is limit yn? Limit yn equals limit n to the power 1 by n. We know that limit n goes to infinity, limit n to the power 1 by n is also 1. That's a familiar result. So we have, here 1 less than or equals, we can combine these two. That is 1 less than or equals n to the power 1 by n square. But n to the power 1 by n square less than or equals n to the power 1 by n. 1 is treated as xn, that is chosen as xn. So sequence xn less than or equals, suppose it is yn and less than or equals, choose it is z, not yn, it is z. So xn less than or equals yn less than or equals z, where yn equals n to the power 1 by n square. Okay. So we have xn less than or equals yn less than or equals z, and also limit xn equals limit zn equals 1. Clear? So these are the two conditions, basic conditions of Skew's theorem satisfies here. Why? One is xn less than or equals yn less than or equals zn, and limit xn equals limit zn, that equals 1. From here, by using with the help of Skew's theorem, we can conclude that. We can say that sequence yn converges to where? Converges to its limit. The limit of xn and yn, that is xn and zn, that is 1. That means sequence yn converges to 1 means limit yn equals 1. What is yn? As our choice, yn is n to the power 1 by n square. So it is limit of n to the power 1 by n square equals 1. So this is our answer. Limit n to the power 1 by n square equals 1. So this problem is solved by using or with the help of Squeeze theorem. Okay. Clear. Similarly, you can find out the limit of n factorial by 1 by n square. N factorial by 1 by n square. That's again, you can solve that problem by using this Squeeze theorem also. Clear.